Hello, hello, hello. Welcome to the session. How are you all, my dear friends? And right now, we are here. Why? What is the reason? Why sir is here? So the thing is, we are going to cover our very first chapter of physics, that is light, reflection and refraction, and this is what we are going to cover. But the amazing fact is, sir, how much time it will take? What is the weightage of this chapter? How we are going to cover all this? Don't worry. Don't worry. I will be taking all the topics related to this chapter. And the amazing factor is, this chapter carries one of the highest weightage in the board examination, that is nearly 6 to 9 marks. That means out of 25 marks, you would be able to secure 8 to 9 marks very easily once you are done with this chapter. So this one short lecture right in front of you, I am standing your Laddu sir, your Vikas sir, and I will be taking light, reflection and refraction. But the point is, sir, what is the meaning of light? That is the very first question most of the students asked me. Sir, what is reflection or what is light? Tell me everything. One by one, I will be taking everything. First of all, the thing is, what I am going to cover. That is the major important thing. Right. So I will be covering all the topic, that is reflection, spherical mirrors, sign convention, rules for the formation of images, then after refraction of light. On the basis of that, spherical lenses, formation of images by lens, and after that, power of lens. Clear? Welcome and to the class. Now over here is, sir, what is a light? That question been asked in a 1 mark question. What is light? The thing is, light always described, that is a form of energy. First of all, we need to understand what light is. So light is a form of energy which gives us the sensation of vision, through which we are able to see. Consider if there is a complete dark in the room, will you be able to see me? No, sir. This is not possible, sir. Right. So you won't be able to see me. But the thing is, I am having something over here. You can see there is a light which is placed over here. The reason is that you would be able to see me in a very good manner. That is why the light is useful. So light is a form of energy which gives us sensation of vision, and through which we are able to see things around us. Okay, sir. But how it is traveling? So the light is traveling in the form of energy in a small packets. How it is coming? In a small packets, and that packet's name given by the scientist, that is called photons. So the light is traveling in terms of photons. Okay, sir, that is clear. Sir, how the light will travel? The next question, how the light will travel? And the light is always traveling in a straight line. How does it travel? In a straight line. You may perform that experiment. Consider you are having one page. Consider that. And I am going to roll that. And if I want to see you from one side, what is going to be happen? You would be able to see me, or I would be able to see you. What if I am going to make a twist? Sir, you cannot see us. You cannot see us in that case. Why? Because the light which was incidenting towards you and coming towards me, that was traveling straight. Because this is twisted, it is not be visible to us. That is the thing. This is why we are able to understand the light is always traveling in a straight line. Clear? Yes? Rest? Now the thing is, yes sir, what else? Sir, what will be the speed of light? What will be the speed? Sir, is it very fast or slow? So light over here, when we talk about vacuum, when there is no atmosphere, the speed of light will be, sir, 3 times 10 to the power 8 meter per second. This will be the speed of light in vacuum. Now another question. Sir, what will be the speed of light in air? So that is approximately, it is going to be, slightly decrease. It is going to decrease a little bit, but it will be still that much high that we will consider that the speed of light in air, that will be approximately equals to 3 times 10 to the power 8 meter per second. As simple as that. Clear? Okay, sir. We have got this. So what is the source of light? How we would be able to understand the light is coming? The light is coming from where? So I would be saying, beta, the light is coming from a source. Light is coming from a source. Sir, what is source? Through which the light is coming. So it says that the source of light is an object from which the light is given out, maybe natural or maybe man-made. Sir, maybe natural, maybe man-made means. So when I'm taking the example of natural sources of light, I will be writing sun, star, stars. These are the examples of natural sources of light. Natural sources of light. Whereas when I'm talking about the man-made, sir, we know that that is quite an easy man-made. So lamp, LED bulb, or bulb directly you can write, or bulb you can directly write, etc. There are so many examples related to that. In the chat box, you tell me what are the others man-made sources of light. You write down in the chat box. I want to see how many of you know about the man-made sources of light, the examples of that. So give me in the chat box if you know about it. Let me check how many of you are familiar with that. First of all, beyond this, if we are talking about source, that means the light is coming. The second thing is what we are, what I am. I am an object. Consider, I am an object. That means if you are looking at me, that you are looking at an object. The image will be there. The image that you are seeing, that is an image, but you are looking at an object. The TV standing over there, the TV mounted over there, the camera, this board, this is what object is. This is what object is, but exactly what we are looking at, or what we are actually obtaining. We are obtaining images of these objects. We are obtaining images of these objects. So in that case, the images, so images will be of two types. Images will be of two types. Sir, why two types? Why two types? Because it is a property. There will be two kinds of images. There will be two kinds of images. So what are these? First of all, have you ever gone to see a movie in a theater? Have you ever gone to see the movie in a theater? Yes or no? Dubeji, do you know that? Have you ever watched a movie in a theater? Yes, sir, we have gone. We have gone. We have watched Durandar on a big screen. On a big screen. Yes, sir. Ari. Yes, sir. We have seen that. We have seen that on a screen. So there will be one of the kind of the image where the image will be obtained on screen. Clear? There will be one image that will be obtained on screen. There will be second kind of image where the screen is not required. Just like you are standing in front of plain mirror, looking at yourself. Okay, I'm looking handsome today. That is the second kind of image. That is a second kind of image. If I need to elaborate that, so the images which do not require any screen, which do not require any screen, or which cannot be obtained on screen, one and the same thing, which do not require any screen or which cannot be obtained on screen, such images are called virtual images. Such images are called virtual images. Second one is a real image. Second one is a real image which says it requires which can be obtained on screen, which can be obtained on screen, obtained on screen. These are called real images. Fine, sir. Example, sir. Example. Give us example. Example. We need examples. Okay. For this projector screen. Have you seen that projector screen in the school? Of course, you might have seen that. Possibly you might have seen that. Projector screen. Movie theater screen. Movie theater screen. Correct? Correct. Whereas the images which do not require any screen, that will be obtained in a plane mirror. That will be obtained in plane mirror. There are other sources also where we would be able to find the virtual images. Clear? Now the thing is, sir, what is that inverted mean? Sir, what is that erect mean? So that means if you are standing like that, the image is like that. That means that is an erect image. Upside up, head will be up only. If you are standing in front of the plane mirror, head is at the top. The image, the head will be at the top only. But whereas in the inverted image, bacha, it is going to be opposite. It is going to be opposite. That means if the object is like that, the image will be exactly opposite, inverted. inverted. So in that case, whenever there is a real image, it will be inverted. Wherever it is a virtual image, it will be erect. That is the property. That is the property, and these are the two kinds of images that we need to take care. We need to learn about all these two. Second thing, what is a medium? What is a medium? Very good answer. Very good answer. Those who are writing convex mirror, that is the another example of that. Very good job done. Over here, the medium is the substance through which the light propagates. So that means the light is traveling in the air medium. What is that medium through which I am surrounded with? Air medium, sir. You are not doing scuba diving, sir. You are not underwater, sir. You are in the air medium. That means through which the light is propagating, that particular substance is called medium. Yes, yes. So there is one question: can a plane mirror be forming a real image? It can. It can if the object is virtual. But unfortunately, that particular part is not given in the 10th class syllabus. Image can be formed. A real image even can be formed by the plane mirror, but the object has to be virtual. Object has to be virtual. So that is one of the aspect. In case if you ask, so I answered it. Fine. Okay, sir. We have got this. Now the thing is talking about the reflection of light. Reflection of light when the light is striking and coming back. When the light is striking and coming back. As simple as that. As simple as that. Sir, we have done this. We had already done this. What you had done? Sir, we had a torch. The light which was coming out from the torch, that was directed towards the plane mirror, and the image was obtained on the wall. That means according to the definition, the bouncing back of light, simple, the bouncing back of light, that phenomena, if the light is coming back in the same medium, that is called reflection of light. Sir, clear, sir? First class, sir. No problem, sir. The bouncing back of light coming into the same medium, that is called reflection of light. Fine. But there are two types of reflection. There are two types of reflection. The one is regular reflection. Other one is irregular or diffused reflection. It is you the types of reflection they are not talking about you. You are regular in school and irregular in school. No, but it is a pattern. It is a kind of pattern. So what kind of pattern it is? The thing is, if there is a very smooth surface, I'm talking about plane mirror. I'm talking about plane mirror. Are you getting this? If the surface is smooth, so what has happened with the plane mirror? Sir, it was a very smooth surface. One side was polished. It was a silvered layer given on the one side. It was a smooth surface. So what is going to be happen? So in case, if the parallel light rays are coming, incidenting on the surface on plane mirror, it will be bouncing back parallelly. Such reflections are called regular reflections. Whereas if the lights are coming parallel, but if the surface is irregular, in that case the light will be going the diffused in the various direction. Such reflections are called irregular reflection. Fine. So the definition says, when the reflecting surface is smooth and well polished, the parallel rays falling on it, the reflected parallel to on it. Fine. Similarly, on the opposite, what you will find? We will find that when the reflecting surface is rough, the parallel rays falling on it are reflected in different direction, also known as diffused reflection. Clear to everyone? Hi Manvi. Fine. Clear. Yes, sir. Now the thing is, the diagram is clear, sir. We got to know about that. What are the laws? What are the laws of reflection? There are two laws. The very first one, incident ray, reflected ray, normal, all lie on the same plane at the point of incidence. Sir, I am confused about this. What is incident ray? What is reflected ray? So, to make you able to understand, if you look into this diagram, the ray which is coming, such rays are called incident ray. Fine. Whereas the light rays which is going back after striking on the surface, that is called reflected rays. So what is normal? So in mathematics and physics, normal is nothing but perpendicular to the surface. So this is perpendicular to the surface. Yes, perpendicular to the surface. Sir, clear, sir? perpendicular to surface, any point. So over here, the angle which is making between, the angle which is forming between incident ray and normal, the angle formed between incident ray and normal, that is angle of incidence. Sir, what is angle of reflection? The angle formed between reflected ray and normal, that is called angle of reflection. Yes, yes, Manvi, you can, no problem. Yes, normal is perpendicular. So according to the first law, what it says, the incident ray, reflected ray, normal all lie on the same plane at the point of incidence. Can you identify this? This is a point of incidence. This is the incident ray which is coming. This is the incident ray which is coming and striking at this point. Sir, reflected ray, this is a normal. They are meeting at this point, at the point of incidence. Law 1 complete. Second law says the angle of incidence is equal to angle of reflection. That means always angle I, always angle I, angle of incidence will be equal to angle R. That means these two angles will be equal to each other. Two laws. Fine, sir. That is clear. Now the characteristics of the images formed by the plane mirror. That is one of the important question. Mark this as the important. Mark this as a important. Why, sir? Because this question being asked again and again, directly and indirectly by the board examiners. Directly or indirectly, they asked in the examination. Either they are going to ask in fill in the blanks or maybe MCQs. So this question is important. So what are the characteristics? How the image will be? So it is like the image of real object is always virtual. Such an image cannot be taken on screen. That is rule number 1. That is characteristic number 1. Second, the image formed in the plane mirror is always erect. I already told you. Upside up, upside up. So upside of the image is upside of the object. Third, size of the object will be equal to the size of the image. When you are getting ready in the morning after taking bath, when you are getting ready for the school, what do you see? You are standing in front of the plane mirror and you realize that the image is short. You are almost 5 feet, but the image is of 2 feet. Is it happening? No, sir. Not at all. The image is also of the same height. That means the size of the image will be equal to the size of the object. There is no change in that. There is no change in that. What are the other characteristics? So the distance between the object and plane mirror. So consider, this is the distance of the plane mirror from the object. So you are standing over here. This is the plane mirror. So the image that will be forming, that will be, this distance will be, if this distance is x, the image distance from the plane mirror will also be at x distance only. Simple. At x distance only. Fine, sir. We have got the point number 4. Fifth property, the image formed in the plane mirror is laterally inverted. You all must have tried all this. Raise your right hand in the front of the plane mirror. What you will observe? Sir, in the image it seems like I have raised my left hand. Have you tried this or not? Have you tried this or not? Yes, sir. I tried this. Even if you have not tried, do it right now. Stand in front of plane mirror. Raise your left hand and it will appear that the right hand has been raised. That particular property, that particular characteristic is called lateral inversion. Lateral inversion. Laterally inverted. So the image is laterally inverted. This is how it look like. Clear? Clear? Fine, sir. We have got. Now the thing is, this was the entire thing related to the plane mirror. Related to the plane mirror. Talking about spherical mirrors. From here, sometimes the student got stuck. Sir, this is difficult. That is very easy. That is very easy. Consider you are having a ball, complete ball, a spherical ball, a big ball. Consider that. Considered, yes or no? Yes. So you are having a big ball. What I am going to do? I am going to take a knife and I am going to cut it. And I'll take this much of part from that ball. What will happen? Sir, you destroyed my ball. No, I have not destroyed it. Just try to understand the concept. Actually, I have considered a complete sphere. I have cut down this small portion. Yes, I am going to polish it from one of the side. I am going to polish it from one of the side. First of all, you need to imagine that if a complete spherical is there, if I'm going to cut a small portion, it will be slightly curved, na? It will be curved, na? Yes or no? Yes, sir. It will be curved. So that is why, because it is a part of the spherical surface, it is known as spherical mirrors. But sir, this seems like glass. No problem. I am going to polish first on this surface, second on this surface, it will become mirror. Oh, that was the thing. This is how it became a spherical mirror. Yes, bacha. This is how it became. This is how it became. The thing is, it was a spherical surface. We have polished one of the side. We have got mirror. Another side, again we have got mirror. This is how the spherical mirror look like. So it says a mirror whose reflecting surface is a part of hollow sphere of glass is known as spherical mirrors. Clear? Fine, sir. We got it. Now the thing is, there are two types. There are two types. Only two types. What are these? Sir, concave mirror, convex mirror. Sir, how we would be able to identify which one is concave, which one is convex? So, if the reflection is taken from the curved inward part, in short, if the reflection is taken from the cave wala part, that cave part, the light is striking and coming back. This cave part, if the reflection is taken from here, it will be considered as concave mirror. Other side is polished. Other side is polished, right? Whereas on the other side, if I am going to polish the cave side and going to take reflection from the bulged outward part, the light is striking on this, then it will be a convex mirror. Simple. So what we had done, we have taken a spherical sheet or a spherical glass, and in that I have cut down this much of portion. And I have polished one of the side. This particular surface is called, or this mirror is called, concave mirror. If I am going to polish the inside wala part, it will be considered as convex mirror. Got it, sir? Clear, sir? Now the point is, there are certain terminologies that we need to remember. Now the point is, so what are these terminologies and definition? Definition I'll give you later, but the point is, what are the terminologies that is required to learn? So the very first terminology that is required, that is the center of the spherical mirror that we are using for reflection. This is the portion that we are using for reflection. Sir, very small part. The midpoint of the spherical mirror, that is called pole. What we call it as? Pole. The midpoint. Okay. We were having this complete sphere. Definitely it would be having a center. That center will be considered as center of curvature. Clear? Yes, sir. This is clear. Now there is a line. Which is passing from center of curvature and pole, that is known as principal axis. That is called principal axis. Clear? So 3 points clear. 3 points absolutely clear. Now the fourth point, the difference or the distance between pole and center of curvature. Distance between pole and center of curvature, that is called radius of curvature, because it is from center. Sir, if you are going to draw a circle, the distance from the center to that particular circumference, that will be considered as radius. So in the spherical mirror, it is known as radius of curvature. Similar thing is going to happen with the convex mirror also. There will be a pole, there will be a principal axis, there will be a center of curvature, there will be radius of curvature. All the points are same. So how we are going to write it down? So the pole is the center of the spherical surface of the mirror. Sir, clear? Everyone. Center of the spherical surface, that is called pole. Center of curvature. So the center of the spherical shell of which mirror is a part, and it lies outside the surface. Clear? Outside the surface. Third point. Point number 3. Principal axis, an imaginary line passing through the center of curvature and pole, that is called principal axis. Sir, point number 4. Principal focus. Now I am going to define focus. First of all, there is a midpoint. Where between pole and center of curvature, and it seems to be here at the midpoint. That is called principal focus. That is called principal focus. Now the thing is, how we are going to define this? So it says principal focus is a point on the principal axis of the mirror such that rays incident on the mirror parallel to the principal axis. After striking, it is going to meet at that point. Sir, please elaborate. Please elaborate this one. So that will be in this manner. So consider this is a concave mirror. Consider this is a concave mirror. Okay, sir. Got it. There will be a principal axis. Yes or no? Yes, sir. Yes, sir. Now the thing is, this is your pole. This is your center of curvature, and it says if the rays of light coming parallel to the principal axis, this is a parallel line. There are two parallel lines, and after striking on the surface, it will be passing or meeting at a point on the principal axis. Here it is. That is called focus. Clear? Clear? That is called focus. And amazingly, if I am going to measure the distance from pole to focus, that will be considered as, or that will be known as focal length. And similarly, what is the radius of curvature? Distance between pole and center, that is called radius. Radius of curvature. Radius of curvature. And for which mirror I am talking about? For which mirror I am talking about? I am talking about concave mirror. Sir, is there any name, any nickname? Just like we are having, like Vikas Sir is having, like Vicky at home. So, concave mirror known as any other mirror? Yes, beta, because the lights are converging. Because the lights are converging. This mirror is also known as converging mirror. Converging mirror. Yes or no? Yes, sir. Sir, what is going to be happen if we have convex mirror? If we have convex mirror, so this is how it will appear. This is a convex mirror. The cave side is polished. Cave side is polished, and you can draw principal axis of any length. There is no problem, but it should not go out of the copy, right? Sir, I will draw from my copy to the neighbors. No, it should be of the considerable length so that it would be quite easy to draw the diagrams. Clear? So what are the points that I need to mention? Sir, there will be a pole, center of the mirror. There will be a center of curvature. There will be a center of curvature. Sir, how the light rays are traveling? Parallel to the principal axis. Yes, sir. Parallel to the principal axis. Sir, but this is the surface. The light will not go inside. How this is going to behave? Beta, it will diverge. It will diverge. Diverge. So here I need to emerge it back. It will appear to meet. So the image will appear to meet over here. Appear to meet over here. That means the image is going to form inside the mirror. Image is going to form inside the mirror at this point. This point is called principal focus of convex mirror. Okay, sir, clearly got it. Now the thing is, the light rays are diverging. What is the nickname? Sir, this will be known as diverging mirror. Diverging mirror. The another name of convex mirror is diverging mirror. Is that clear to everyone? Clear to everyone about the focus? Yes, sir. Focus. Also remember, where is the focus lying on? Where is the place where the focus is lying? Sir, on the left side of the pole. On the left side of the pole. For whom? Sir, for concave mirror. Where is the focus lying over here? Sir, on the right side of the mirror. On the right side of the convex mirror. Always remember that. Always remember that. Sir, is this really necessary to remember? Answer is yes. Why? Because further, when you will be solving the numerical, that is going to really helpful, bacha. Very helpful. Fine. Okay, sir. Clearly got it. Now, principal focus is a point on the principal axis of the mirror. So, if the parallel rays are incidenting, it will reflect and meeting or appear to meet at this point. That is called principal focus. As I have already drawn the diagram. Clear? Fine, sir. What about radius of curvature? What about radius of curvature? Radius of curvature is the distance from pole to center of curvature. Focal length, distance from pole and principal focus. We had already done that. Correct? This is the only definition that you need to write. Right? Distance from pole to center of curvature. Sir, is it necessary to write down pole? Answer is yes, because all the distances will be measured from pole. All distances. Object distance, radius of curvature, focal length, image distance, not that distance that you are having, long distance relationship, not that one, but all the distances related to the mirror, that will be from pole. Fine. Aperture, so there is another definition in case, so that is the aperture of the spherical mirror gives the size of mirror. They're talking about this size, this much size, that is called aperture. Generally, this question never been asked in the board examination, but yes, you should be familiar what aperture is. Sometimes in the competency based question, in case if they are going to provide you such question, then you would be able to understand what aperture is. Clear? Talking about this, the diagram. So this is what? Concave. This is what? Concave mirror. Concave mirror or converging mirror or converging mirror. Similarly, this is convex mirror. Convex mirror, also known as diverging mirror. Also known as diverging mirror. Clear? Now there is one question over here. What is that question? Question is quite simple. Express the relation between focal length and radius of curvature of the spherical mirror. See, when the experiments were happening to check where is the focal length, what will be the distance, and how this is related to the radius of curvature, the conclusion was quite simple, that the radius of curvature is equal to twice of focal length. As I already told you, it will lie at the center. Focus will lie at the center. So radius of curvature is nothing but equal to twice of focal length, or it can also be written like that, or focal length is equal to radius of curvature by 2. This is a very simple relation that you can remember. Half of that, exact midpoint. Fine, fine, clear, sir. Now there are rules for the formation of images. So what are the rules? See, we have like spherical mirrors, that definitely the images are going to form. So we need to follow certain rules so that we would be able to draw the different images. Fine. So there are certain rules that we are going to follow. The very first rule that says a ray incident parallel to the principal axis actually passes or appears to pass through focus. While deriving the focus, I have drawn the diagram related to that. If you can exactly recall, this is how it seems. If a ray of light coming parallel to the principal axis, it will meet at focus. Whereas if a ray of light coming parallel to the principal axis, it will be diverging but appear to meet at focus. Point number 1. Rule number 1. Fine. Second, if a ray of light passing through center of curvature, it will reflect back along the same path, because it is a center na. So if the ray of light passing through center of curvature, after reflection it will be following the same path. No such deviation you would be able to see. Similarly, in convex, if a ray of light appears to pass through center of curvature, it will be reflect back along the same path. That is rule number 2. Fine, sir. 2 rules are absolutely clear. Rule number 3 and 4, which clearly says, if a ray of light passing through focus, after reflection it will be going parallel to the principal axis. Fine. Similarly, if a ray of light appears to pass through center of focus, it will be going parallel to the principal axis. Rule number 3. And the last rule is very simple. If any ray of light incidenting on pole, after reflection it will be going back by making the same angle. That means angle I equal to angle R. Right? Similar happening with the convex mirror. Equal angles will be formed. Angle I will be equal to angle R. Fine? Clear? This is done. After that, the image formation. There are total 6 cases. That we are going to discuss in terms of concave mirror. Total 6 cases. Fine, one by one. First of all, sir, what are the places where I am going to place the object? That is the question should come into our mind. Sir, what are these places where I'm going to place the object? So first of all, I will start with the very far distance. The distance will be considered as infinity. There is one more thing. If the object is kept at very far distance, the light rays which are coming, that will be considered parallel to the principal axis. These are the two things that we need to think of. First of all, the mirror that you are taking, that is very small, very small. So the object you are considering at very far distance, that will be considered as infinity, and the light rays which are going to incident, that will be considered as parallel light rays. Parallel light rays, very good. Now in this, so that is the case number one. After that there will be second case, that will be just behind the center of curvature, case number two. Third, we will be placing the object at center of curvature. At center of curvature, consider here will be, here there it will be a center of curvature, yes or no? It will be a center of curvature at this point, yes. So first of all, I will be taking object at infinity, then object beyond center of curvature, then at center of curvature, then between center of curvature and focus, then at focus, then between P and F. These are the six cases. No problem. One by one, we are going to discuss. The very first case, when the object is kept at infinity, formation of image. When the object is placed at infinity, the image will be forming at focus. How this is going to be formed? So the light ray is going parallel to the principal axis, or after converging, light is going parallel to the principal axis after converging, and they are meeting at a point that is called focus. Case number one. Case number two, when the object is placed beyond center of curvature, where I have kept the object beyond center of curvature, so in that case, where the image will form. So here comes the diagram related to that. So if the object is kept beyond center of curvature, then the light ray, follow the rule. First of all, follow the rule. So if the ray of light going parallel to the principal axis, after striking, where it goes? Sir, it passes through focus. Rule number one used. Second, if the light ray passing through focus after striking, how will it pass? Sir, it will go parallel to principal axis. So this is going parallel to principal axis, and finally it is going to meet over here at this particular point, and through this we would be able to form an image. Yes sir, can you see the difference over here? Can you see the difference? Object is large, image is small. Even in the previous case, what we have seen, object was large, but image, what you have seen? Sir, it was point sized. A point has been obtained. Second, sir, a screen would be required. What you would be required to obtain the image? Sir, screen. That means real and inverted. Array, you have got it or not? And third property. What will it be? Where it has formed. Sir, it has formed at focus. We have understood this. Properties we already knew. You need to remember all the properties, and by practicing this, it will be quite easy. Sir, in the second case, object was kept beyond the center of curvature, and image that you have got, that is, sir, we have got image that is between center of curvature and focus. Point number one, this is what you have got. Second, what is the size? Sir, smaller one, diminished. Smaller, also known as diminished. So diminished, smaller one, diminished. Third, what is the nature of image? Sir, actually the lights are meeting over here. The light rays are meeting over here. We require a screen that is real and inverted. Yes, sir. Clear, sir? Now I am going to shift the object towards center of curvature. Fine. third case, when the object is placed at the center of curvature, what is going to be happen? So in that case, if the object is at center, if the object is at center, center of what? So center of the entire sphere. So what will happen? What will happen? Sir, first of all, I will follow the rules. First of all, what you are going to do? You will follow the rules. Yes or no? Yes, first rule says, if a ray of light going parallel to the principal axis, it will be passing through focus. Yes, sir. Yes, sir. Second rule, opposite to that. If a ray of light passing through focus, going parallel to the principal axis, and finally, what you have observed? Sir, image is actually meeting at this point, which is exactly just at the center of curvature, but opposite. Yes, sir. That means if the object is at center, it will be at correct. It will be at center of curvature. So the image will be at center of curvature. Fine. Look at the size. It seems similar, na? Seems similar, na? Yes, sir. It will be of same size. It will be of same size. Same sized. Third, nature. In air, you won't be able to get this. You need a screen. You need a screen. That means real and inverted. That is the third case. That is the third case. This is how the image is going to form. Clear? Fine, sir. What about fourth one? Now I am again going to shift my object towards pole. So that is the location between center of curvature and focus. Yes, sir. Ready, sir? Object kept between center of curvature and focus. Follow the rules. A ray of light passing parallel to the principal axis after reflection passing through focus. Yes, sir. Second, ray of light passing through focus after striking parallel to principal axis. Parallel to principal axis. Yes, sir. Clear, sir. Image is forming, sir, beyond center of curvature. Image is forming beyond center of curvature. Yes, sir. No problem. So the image over here, what you are getting? Sir, image forming beyond center of curvature. Beyond center of curvature. Sir, I can recall that when the object was beyond center of curvature, image was between center of curvature and focus. Here in this case, when the object is at between center of curvature and focus, image is beyond center of curvature and focus. Sir, that is really good, na? There would not be any difficulty in learning, na? Yes, there will not be any difficulty in learning. So beyond center of curvature, but look at the size. Object size is this. Image size is this. Sir, that is going to be enlarged. Big image is going to be obtained. And the nature of image, again it is going to be real and inverted. Perfect, sir. No problem. That is case number 4. Now I am again going to shift my object towards focus. Remember that case when the object was at infinity? Remember when the object was at infinity, where the image was forming? Sir, when the object was at infinity, image was forming at focus, sir. Remember, sir. Now I am going to place the object at focus, where it is supposed to form. Infinity. Ha, sir. We got. Yes, sir. Yes, sir. So this is what we are looking at. So when the object is at focus, consider this. So what is going to be happen? So the light rays which are passing from the focus, it will be going parallel to the principal axis. Sir, but the light rays are not meeting with each other, na? Light rays are not meeting with each other. Then how we will consider that the rays are meeting at infinity? So in the mathematics, we have gone through this property. The parallel light rays never intersect each other, but they meet at infinity. Yes, this is what we are going to write in the formation of image. So image over here, case number 1, it will be meeting at infinity. Second, it will be highly enlarged. The size will be highly enlarged. Third, the nature will be real and inverted. Yes, sir. Because a screen would be required finally, so that you would be able to get the image of that. And last case, and count my words, very, 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 very important. June is going on. Let me give you the prediction. One of the question in the board examination will be appearing from this particular case. In the board examination, which will be happening in February, I'm telling you right away, this from this case, one of the question will appear in the board examination, and you will remember that. So the case number 6, it says, if the object is kept between focus and pole, what will happen? What will happen? Rules, sir. Light ray parallel to the principal axis passing through focus, and light ray which is passing through center of curvature, it will be going undeviated. But if you observe these two light rays, they are deviating. They are going in different directions. They are never going to meet. In that case, they will appear to meet behind the mirror. It will appear to meet behind the mirror, and this is how it will look like. Sir, in this case, the image is upright. It is not an inverted image. Yes, exactly, it is not an inverted image. So the image over here is, that is forming behind the mirror. First of all, it is going to be behind the mirror. Second, size is enlarged. And third, because there is no screen required, it is forming inside the mirror. It will be virtual and erect. Have you ever been to the dentist? Have you ever been to the dentist? So they are having a spatula like that. There is a spoon kind of structure where at the top of that there is a concave mirror mounted. Now the dentists try to do they usually do that. So they insert that instrument inside that so that they can see virtual erect image, enlarged image, and they can try to find out the cavity very easily. That is also this particular thing that also used as a shaving mirror in the various hotel and resorts. They are mounting that spherical mirror, concave mirror only that will be used as shaving mirror, so that you can do makeup, you can dress yourself, and for the men they can do the shaving by using that mirror, and that is going to be very helpful because the size seems to be bigger because it is forming enlarged image. That is the property, and there are various other characteristics and the uses of concave mirror that I will be discussing. So these are the 6 cases that we have discussed. What are these? Sir, object at infinity, image will be at focus, highly diminished, real and inverted. If the object is beyond C, it will be, okay, opposite to that, at focus, it will be at infinity, highly enlarged, real and inverted. Opposite to that, beyond C, between F and C, diminished, real and inverted. Opposite case, between F and C, object is beyond C, enlarged, here it was diminished, nature is real and inverted. Sir, at C, this is the center, no changes, only at C, same size, real inverted, and that is the last case where the object is between P and F, image will be behind the mirror, enlarged, and at last virtual and erect. Very important case. Sir, what is going to be happen when the image is required to form in convex mirror? There are only 2 cases. Simple, only 2 cases. First, when the object is kept at infinity, this is how it looks. When the object is kept at infinity, the image will be forming at focus, sir. Of course, focus. So the object is at infinity. If it is supposed to pass through center of curvature, it will reflect back. If the ray of light appears to pass through focus, it will be going parallel to the plane mirror, parallel to the principal axis, and if the light ray is incidenting on pole, it will be reflecting back. Finally, what we have found, the image is forming over here, and according to this, when the object is at infinity, image will be at focus, second point sized, and nature will be virtual and erect. The amazing property over here is the convex mirror always give you virtual erect image. Convex mirror always give you virtual erect image. Second case. Second case is amazing. Now put the object anywhere between infinity and pole. Anywhere. Anywhere. No problem at all. Just put the object anywhere between infinity and pole. What you will find? So I have kept the object somewhere at this point. So what you will observe? Sir, we need to follow the rules. So if the ray of light appears to pass through center of curvature, it will be going back along the same path. Yes, yes. And if the ray of light supposed to pass through or passing parallel to the principal axis, it is diverging and it will appear to meet at focus. Now in both the cases, the image is meeting over here. The image is meeting over here. That is between pole and focus. Pole and focus. Yes, sir. Yes, sir. Okay. So in that case, the property is image between pole and focus. Second, size. What is the size? Greater or smaller? Greater or smaller? Is it enlarged or diminished? Enlarged or diminished? Sir, it will be diminished. Diminished. And third, it will be virtual and erect. Virtual and erect. Yes, sir. All the image formations are done. All the image formations are done. These are the uses. So where we are going to use this? Concave mirror, as I told you about the dentist, they are going to use so that the image can be formed. And last, one of the factor, as a solar furnace, as a torch light, as a car headlight, as a solar cooker. So there are various examples where you would be able to use concave mirror, right? Whereas talking about convex mirror, you must have seen the rear view mirror, no? Right? Or the mirrors mounted at the blind turns. Mounted at blind turns. These are the mirrors. They are nothing but convex mirror, bacha. Nothing but convex mirror. Why? Because it is going to give us a smaller image. Wider range can be covered. This question been asked on the board examination. Why we are using convex mirror as a rear view mirror? Or which mirror will be used as a rear view mirror and why? Answer is quite simple. It gives us a smaller image. It covers the wide range. This is why we are using rear view mirror as a convex mirror as a rear view mirror. Okay. Now I can remember. Yes, yes, hi, Devi or Sajjano. Yes, yes, fine, sir. Now the thing is sign conventions. What else? Once we are done with the image formation, it is highly required to know about the numericals or how to solve numericals. But before that, we need to understand about the sign convention. We need to understand about the sign convention. Sir, why is it required? Because for solving numericals, there are certain things that was already been decided, already been discussed and fixed. Just like, let me give you an example. Every time we will consider that the object will be kept at the left side. All the time. All the time. What we are going to consider? The object is always kept at the left side of the mirror. Now you can adjust your mirror. You adjust your mirror in such a way. But what consideration that we are going to take? Object will always be on left hand side, sir. No doubt. So such kind of consideration being taken and based on that, the sign convention being given. So in a language format, it says all the distances are measured from pole. As I already told you in the starting, the distances will be measured from pole. The incident ray taken from left to right. That means sign convention, if you know about the Cartesian coordinate system. If you know about the Cartesian coordinate system, yes sir, in mathematics we got to know about this, where sir there will be a plus x-axis, there will be a minus x-axis, there will be a plus y-axis, minus y-axis, yes or no? Yes or no? And this will be origin. This will be origin. This much we know. My point is, consider the pole is kept at origin. That means at this point, whatever mirror you are considering, just place the pole of that particular mirror at origin. Now I am saying Now I am saying the object is kept on the left hand side. That means whatever distance that I am going to measure over here, that will be on the negative x-axis. Negative x-axis. So whatever is there present on the left hand side of the mirror, that will be negative. On the right hand side of the mirror, that will be positive, sir. Positive. So on the left hand side, everything will be negative. On the right hand side, everything will be positive. Sir, what about height? So if any object is placed over here, that is along the positive y-axis. So height of the object always be positive. Height of the object always be positive. Sir, what about real image? What about virtual image? Okay. The real image, if the image is real, that means it is going to be downward. Real and inverted, na? It is going to be downward. Sir, on negative y-axis. So the height of image for real inverted case, it will be negative. It will be negative. For virtual and direct, it will be positive because it is along the positive y-axis. It was that easy. It was that easy. Yes, these are written in the form of sentences. Like all the distances will be measured from pole. We have considered pole over here. Incident ray taken from left to right. That means if the object is kept over here, the light rays will going in this direction, left to right. The distance is measured in the same direction as that of incident ray to be taken as positive. So if anything that I am going to measure, if it is towards the direction of incident ray, that means left to right, that will be positive. That will be positive. That means it is going on the right hand side of the axis or right hand side from the pole. That means on the right hand side. Positive. Yes, sir. Distances measured opposite to the incident ray. So if you are going to measure anything on the opposite, negative. Negative from the pole. Yes. Yes. Real and inverted in positive x-axis here. Just giving you an example about that. I have not placed any mirror so far. Just giving you an example about that. We have not placed any mirror. In case if you feel that no sir, this is wrong. In case of mirror, let me remove this. What we can do? Will that be okay? Will that be okay? Happy? I'm just only here to tell you, in case of real and inverted image, it will be lying along the negative y-axis. In that case, it will be negative. The height of the image will be negative. Fine. So the distances measured opposite to the incident ray will be negative. Distances measured upward perpendicular to principal axis, positive. Positive. And negative if it is downward. No matter if it is on the left hand side or on the right hand side, it will be considered, the height of image in that case will be considered as negative. Do not make so much problem in that, sir. In the mirror we have understood that. That is okay. The concept lies over here is, if something in that manner, height of object positive above the principal axis, if it is a real inverted, it is going to be negative, downward, no matter on the left hand side or right hand side. Fine. So these are the sign conventions. Okay, sir. What next? Now here comes the formula. Mirror formula. If you need to find the value of image distance, object distance or focal length, we are provided with one of the formula, that is 1 by image distance, 1 by image distance, and that is the representation is V, plus 1 by object distance representation is U, that is equal to 1 by focal length. That is 1 by V plus 1 by U equals to 1 by F. That is the mirror formula, also known as mirror formula. Sir, how this is going to be useful to find the value? See, what you have to do, you have to put the values, but the thing is, we need to consider the sign convention. If you are going to use it, the life would be quite easy. The life would be quite easy. Yes, an object will always be considered as negative. Always be considered as negative. Right? Even in class 11 and in class 12, and for that we always consider that, because all the formulas that has been derived, that was considered in that manner, that you are placing the object on the left hand side. Fine, sir, we have got this. Now talking about magnification, after that the numericals will appear. Now over here over here, if you see the magnification, generally what happens whenever I'm asking about magnification, ki bacha, what is magnification? The student be like, sir, magnification, that magnifying glass. No, answer is not like that. Magnification gives you the ratio. Ratio of what? Ratio of height of image to the height of object. How large or what is the proportion of the height of the image that we are getting as compared to the object. Second, what is the ratio of the image distance by object distance? Image distance by object distance, it can be represented as magnification, that is equal to height of image to the height of object. Representation is hi by ho, and equal to v by u, that is image distance by object distance, but with a negative sign. With a negative sign. There will be no negative sign in case of lens, but over here negative sign, that is magnification equal to minus v by u, that is equal to height of image by height of object, right? So there is something that we also got to know. What it is? There is a relation between height of object and height of image, and image distance and object distance, that is hi by ho, that is equal to minus v by u. Directly you can use it even in the numericals. Directly you can use it, right? So there is something that you also need to know. One thing. What is that? If you are provided with magnification equal to 1, what does that mean? What does that mean? If you have got magnification equal to 1, that means if formula of magnification is height of image to height of object and you are getting 1, that means the both heights are same. Both heights are same. That means the height of image, height of object, both are same. One thing, height of image, height of object, both are same. And when you were getting the same sized image, sir, when the object was at center of curvature, that means the object was kept at center of curvature. Clear? Yes. Second, there is a positive sign or no sign given, that is considered as positive sign. That means the nature of image is going to be virtual and direct. Sir, what if the negative sign is there? Nature will be real and inverted. In that case, bacha. If positive sign, nature will be virtual and direct. For negative, it will be real and inverted. Yes, sir, we got to know. We have clear. So if magnification is 1, it will be a real image. If magnification is positive, it will be virtual image. Now we have got an idea. Now we can solve questions. Yes, sir. Now there is one question right in front of you. It says an object 4 centimeter in size placed at distance 25 centimeter from concave mirror. First of all, in that case, we need to write down the values. So the object distance that is given as 25 centimeter. And as I told you, the object will always be placed on the left hand side. That means I am considering negative 25. So the object distance will always be negative, sir. No problem. Concave mirror, which mirror it is? Sir, concave mirror, focal length is 15 centimeter. Can anyone tell me what will be the focal length? Positive or negative? Sir, that was the concave mirror. Light is striking, converging on the same side as the object. Will it be positive or negative? Everyone, answer this. Will it be positive or negative? Yes, negative, sir. On the same side. Concave mirror. Sir, focus lies over here on the left hand side. It will be negative. Very good. So find the position, nature, height of image or size of image, and height of object also given. How much? Sir, 4 centimeter. How to solve? First of all, I'm going to calculate the value of V. You also try. Solve in your copy and get the answer. I'm also trying, like 1 by focal length, that is equal to 1 by V plus 1 by U. So 1 by focal length is negative 15. That is equal to 1 by V plus 1 by minus 25. Minus 25. So 1 by V, that is equal to minus 1 by 15. This is plus minus minus. It will be going on the other side, will be positive. So 1 by 25. So 1 by V, that is equal to 15, 25. LCM will be how much? 75. 75. 5 plus 3. So 1 by V, that is equal to minus 2 by 75. By taking reciprocal, I will be getting minus 75 by 2 or minus 37.5 centimeter. Sir, we have got the value. Yay, yippee. Are you also getting the same value? Are you also getting the same value? Yes? Are you also getting the same value? Yes or no? Correct. Second thing, nature. See, the image distance is negative. That means on the same side. On the same side. That means it is going to be real and inverted. Real and inverted image. Real and inverted image. Fine, sir. Third one, height of the image. Height of image. Height of image. How we will be able to find the height of image? Sir, you already told us a relation. Hi by Ho, that is equal to minus V by U. Yes? Yes? So Hi divided by height of object 4 centimeter, that is equal to minus, what is the image distance? Sir, minus 75 by 2. And object distance, sir, minus 25. Yes or no? Yes or no? Yes, sir. Yes, sir. From here, it is going to be positive. So this will be 75 divided by 50 with a negative sign. 25 2s are, 25 3s are. So that is going to be minus 3 by 2. Height of image, that will be minus 3 times 4 by 2. On cancelling, you will be getting minus 6 centimeter. Yes or no? Minus 6 centimeter. Yes. Yes. Yes, sir. Height of image also appeared. Minus 6 centimeter. That means large. Larger than object. Array object size was 4 centimeter, image you are getting 6 centimeter. Right? And as well as with a negative sign. That means nature is real and inverted. That is the confirmation. That is the confirmation that we are getting from here. The nature of the image is real and inverted. Very good answers. Very good answers. Perfect. 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 Fine. Okay, sir. Next question. A converging mirror forms a real image of height 4 centimeter. A converging mirror forms a real image of height 4 centimeter. That means the image is already formed and the nature is real. Image already formed. Image is real. So what I am going to write? The height of image given as minus 4 centimeter of an object of height 1 centimeter. That means height of object given as 1 centimeter. Is that clear? If you are going to read the question, that is going to be quite okay. Right? Placed 20 centimeter away from the mirror. So the converging mirror forms a real image. The object of height this much placed 20 centimeter. That means the object is placed at minus 20 centimeter. Yes, sir. Calculate the image distance and focal length. That means we need to calculate value of V and value of focal length. Will you be able to do that? Will you be able to do that? Yes or no? Yes, sir. Hi, Ho, U. 3 values are given. We can calculate value of V. So in the first part, we are going to use relation Hi by Ho, that is equal to minus V upon U. What is the height of image given? Minus 4. Minus 4. Yes. Minus 4. Height of object 1. That is equal to minus height of image. Sir, I don't know. U, that is minus 20. Minus 20. Minus minus cancel. V value is how much? Minus 80 centimeter. Have you also got the same value? Minus 80 centimeter. Yes or no? Minus 80. Minus 80. Yes, sir. So the second one, what I need to calculate? Focal length. What I need to calculate? Focal length. You need to focus. Guys who are watching this lecture, you need to focus. that you need to find the value of focal length. Are you getting this? Focal length. How you would be able to evaluate? Sir, I will be applying mirror formula. I will be applying mirror formula. That is 1 by f, that is equal to 1 by v plus 1 by u. So 1 by focal length, that is equal to 1 by image distance, that is minus 80, and object distance is minus 20. So 1 by focal length, that is equal to 80 minus 1 minus 4 it will be, that is minus 5 upon 80. Correct? On dividing, what you will be getting from here? On dividing, what you will be getting from here? 1, 1, 6. Finally, the focal length is coming out as minus 16 centimeter by doing reciprocal. Array, did you get this or not? Minus 16 centimeter. Yes. Yes. Everyone. Yes or no? If you have got this, just let me know. Are you also getting 16? Great. This is how you would be able to solve. So there is one question that I'm giving you as a homework. You need to try this. The values are like object is placed in front of concave mirror. Focal length is 20 centimeter. Right? The image formed is 3 times the size of object. Magnification is given. Magnification is given over here. Calculate 2 possible distances of the object. I'm just giving you a hint about that. Giving you a small hint. Here they are giving the 3 times of the size of the object because the nature is not given. Nature of image is not given. Now, in that case, what you are going to consider? In the first case, you will consider it is plus 3. In second case, it will be minus 3. Minus 3. And by using this, calculate the 2 possible distances. This is what you need to do. This question is wonderful question and you need to try this as a homework. Everyone. Fine. Talking about the second phenomena. Reflection is done. Talking about the second phenomena, that is called refraction of light. What was happening in the reflection of light? It was striking on the surface and bouncing back. But there is no bouncing back of light will be applicable in terms of refraction. Then what will happen? So it says when there are two different mediums. So two different mediums. Which one? Maybe air, maybe water, maybe glass, maybe other. But we need to do the comparison. Comparison for what? For optical densities. Optical densities. How it is going to be more denser? Which one is more denser? In that case, where the particles are coming, closer to each other. The one whose particles are coming closer, that will be considered as denser medium. Whereas the other medium will be the rarer one. Over here, consider that they are saying this is an air medium. This is a air medium. This is a glass medium, and we know that air medium will be rarer and glass medium will be comparatively denser. So air medium will be written as, sir, it is a rarer medium. This is a denser medium. And the phenomena of refraction says, if the light is entering from one medium to another medium with different optical densities, it is going to bend. Where bending? Where are you going? With whom you are going? With no one. But the thing is, it will be bending towards the normal if the ray of light is traveling from rare to denser medium. Acha sir. Okay. What if the ray of light going from denser to rarer, it will go away from normal. Sir, that is very easy. The path of light is going to change. But the question over here is, sir, why is it changing? Question here is, why is it changing? So we have seen that the basic cause that the speed of light got changed. There is a change in speed of light on going from one medium to another. Oh, that is the reason, sir. That means the speed of light changes from one medium to another. Yes, in air there will be another speed. In water the speed of light will be different. In glass there will be another speed. Okay, that is the reason there is a bending. Yes sir, we have seen this. We have seen this when we are inserting the pencil into the glass full of water, it appears to bend. Reason? Refraction. Reason? Refraction of light. That is why the refraction is the separate phenomena. So when the light is coming from rare to denser, it will be bent towards the normal, or moving from denser to rarer, it will move away from normal. Okay, okay. Now laws of refraction. But before that, I would like to tell you one more thing. This diagram. So in that diagram, what you are observing, sir, the light is traveling from air. Light is traveling from air, moving to glass, then again moving to air. So what will happen? Sir, the light ray is coming, making angle I. The light is entering from rare to denser. It will bend, sir, towards the normal. Very easy. Again, it is coming back to the same medium. It will bend away from normal. Yes or no? But the point here is, what if this glass slab is not present? What if I am going to remove this glass slab? What will happen? Sir, the light was supposed to move in a straight line in that manner. Yes or no? The light was supposed to move in a straight line in this manner. Yes? Yes? Yes, sir. Yes, sir. But the thing is, if I am going to measure the perpendicular distance between original incident ray and emergent ray, the light which is finally coming out in the same medium, that ray is called emergent ray. What is that called? Emergent ray. And the perpendicular distance between emergent ray and original incident ray, that is called lateral displacement or lateral shift. That is called lateral displacement or lateral shift. This is what happens when the light is entering from air and emerging out from air medium. Okay, sir. Clear, sir. So what are the laws of refraction? So the laws of refraction says the incident ray, refracted ray and normal all lie on the same plane at the point of incidence. You can see over here. This is the incident ray. This is the refracted ray. This is normal. They are all lying at the interface of the medium at the point of incidence. Yes or no? Yes or no? Yes, sir. Clear, sir. Second, the ratio of sine of angle of incidence to the sine of angle of refraction is constant. So what does that mean? That means sine of angle of I by sine of angle of R, that is equal to constant. That is equal to constant. And this law is known as Snell's law. This law is known as Snell's law. Clear? Clear? So what does that constant exactly representing? Let me give you prior information. This constant is nothing but refractive index. Refractive index. What does that mean? What exactly that means? It means that when we are talking about refractive index, so there are two refractive indexes. First, absolute refractive index. Second, relative refractive index. Sir, why they are two different? Because in absolute refractive index, we are taking the speed from the vacuum. That means the maximum speed of light. That is the maximum speed of light that we are considering. So the speed of light in vacuum. So the refractive index representation is n, sometimes mu. These are the representation of refractive index. And over here that can be written as speed of light in vacuum divided by speed of light in medium. This ratio, this change in speed of light, this ratio giving us refractive index. This ratio is giving us refractive index. So it says the absolute refractive index of medium is defined as the ratio of the speed of light in vacuum to the speed of light in medium. Sir, got it, sir. What else? What is relative refractive index? When the speed of light will not be equal to medium, there will be a separate medium 1. There will be some other medium 1, and medium 2 in that case, the refractive index will be written as refractive index of 2 with respect to 1. Refractive index of 2 with respect to 1, that is called refractive index, relative refractive index. What are the practical applications? Sir, we can see the bending of pencil. One of the example, the bending of pencil because of the refraction of light. Other application, sir, the surface of a swimming pool or the coin placed at the water tank appears to be higher because of refraction. Because of refraction. Now there is one question right in front of you. It says related to the refractive index. Related to refractive index, it says light travels through water with a speed of. So the speed of light in water, that is given as 2.25 times 10 to the power 8 meter per second. Yes or no? Yes or no? What is the refractive index of water? They are asking about refractive index. Okay, sir, we'll calculate. We will calculate very easily. But there is something also given. The speed of light in vacuum, that is 3 times 10 to the power 8 meter per second. What was the formula? What was the formula, bacha, in that case? What was the formula? Sir, refractive index equal to speed of light in air or vacuum by speed of light in medium. That is equal to 3 times 10 to the power 8 divided by 2.25 multiply 10 to the power 8. Both are in meter per second. So units are going to cancel out each other. Units are also going to cancel out each other. So that means the refractive index does not have any unit. Yes, there is no unit. There is no unit. 10 to the power 8, 10 to the power 8 cancel. That is going to be 3 divided by 2.25. On solving, you will be getting 300 by 225. So that is going to be how much? 12. 12. And that is going to be how much? 9. So this is 3. This is 4. Answer will be 4 by 3. So the refractive index is coming out as 4 by 3. Refractive index is 4 by 3. This is how you can solve questions for refractive index. Got it? There are two questions. There is one more question. Light travels through air medium 1 to another medium 2. The angle of incidence and refraction are given. How much? How much? 45 degree and 30 degree. 45 degree and 30 degree. So angle I given as 45 degree. Angle are given as 30 degree. We need to find the refractive index of second medium with respect to first medium. Can anyone tell me what will be the answer? Can anyone tell me what will be the answer over here? Everyone, what will be the answer over here? In this case, sir, we know there is a formula. We know there is a formula. Yes, what was the formula? Sir, refractive index, that is equal to sin I by sin R. That was the formula. And we need to calculate the refractive index. So, I am going to put the value of I, that is 45 degree divided by sin 30 degree. What is the value of sin 45? What is the value of sin 45? So, bachcha, sin 45 degree is 1 by root 2 and sin 30, that is 1 by 2. This is what I am going to put over here. Okay. So, that is equal to 1 by under root 2, that is equal to 1 by 2. Finally, the refractive index, I have got 1 by, so that is 2 by root 2. 2 by root 2 or under root 2, that is going to be 1.414. Are you also getting the same value? Yes or no? Are you also getting the same value? Light does not need any, like it is not depending on the medium. Light can travel. Light can travel. This question that you need to try as a homework. Sir, but this is not related to the apparent depth, that is related to the apparent depth. So there is one formula, that is refractive index equal to real depth by apparent depth. What is apparent depth? Apparent depth is the depth what you are observing from the top. I gave you the example, the surface appears to be higher. The real depth, consider, the real depth was 10 centimeter. But when you were looking into the swimming pool, what you observed? depth is quite less. I can jump, I can swim. Later while jumping you realize this is quite deep. Mama save me. Right, right, right. So in that case, the height that is appeared to you, that is called apparent depth. So even in that question, the real depth is how much? Real depth is how much? 20 centimeter, and refractive index is given as 4 by 3. Let me solve this. 20 centimeter and this is apparent depth. If I'm going to solve for apparent depth, that is equal to 20 times 3 divided by 4. This is 5 and apparent depth is coming out as 15 centimeter. 15 centimeter. Sign questions will appear in the examination. Yeah, it might appear. There is no problem. Sign questions might also appear in the examination. There is no doubt in that. Don't worry. If questions I am doing over here, that means there are possibilities that such kind of questions might appear in the examination. Fine. This is why I came up with the various numericals. So here what we have got. Sir, apparent depth is coming out as 15 centimeter. The actual depth was 20 centimeter. Fine, sir. We got to know about this. Talking about spherical lens, and that is the second last topic of this chapter. What is spherical lens exactly? So over here the lens is a piece of transparent refracting material bounded by two surfaces. So in the spherical lens we have taken one spherical glass. Here we are going to take two, and in that case we will be taking this much of portion from first one, second from the second one, and we are going to take this, and we have got one of the lens. Similarly this much part from one, this much part from two, and on merging we have got another lens. So what are the names? This particular one, the first one that is called this kind of shape, that is called convex lens. What is this known as? What this lens is known as? Convex lens. Convex lens. How you would be able to identify like the lens is convex? That is quite simple. Very easy. Sir, it will be thick in the middle, thin at the edges. Look at the shape. It is thick in the middle, thin at the edges. This is how you would be able to identify. Sir, what about concave? Sir, bacha, it will be thin in the middle, thick at the edges. Sir, was that easy? Is this the definition that we can write in the examination? Yes. Convex lens, thick in the middle, thin at the edges. Concave lens, thin in the middle, thick at the edges. Done. What are the terminologies required? Because in the spherical mirrors also, we had followed some terminologies. Na? So, will there be any pole? No pole. No pole. Then, what will be the term? We are going to use optical center. Optical center, the midpoint of the lens. Midpoint of the lens. Second thing, there are two surfaces that you can see over here. So, there will be two center of curvatures. Sir, which one should I consider for the numericals? Which one should I consider for the numericals? In that case, for convex, you will be considering this as primary, right hand side, the right hand side one. For the concave, we will be considering the left hand side one, this center of curvature, the left hand side one, and for this, the right hand side center of curvature, this one. Why? Because the images will be forming in such manner that we need to take care of. Fine, sir. Got it, sir. Will there be any principal axis? Yes. Passing through optical center and center of curvature, there will be a principal axis. No problem, sir. Sir, will there be any radius of curvature? Yes. What was the radius of curvature? Distance from pole to center in mirror. Here, distance from optical center to center of curvature. That will be radius of curvature. Next, terminologies. Center of curvature. The centers of these spheres are called center of curvature. Aperture of lens is the diameter of the circular edge. This one. Where is the aperture? Bacha, here is the aperture. This distance is called aperture. Fine. Next, principal axis, sir, we know imaginary line passing through. imaginary line passing through both the centers and optical center. What about optical center? It is the center of the lens. There is a point on the principal axis. Optical center. Point. If the light is incidenting on that particular point, the light will not refract. It will go straight. It will go straight. No changes, no refraction, no bending of light. Why? Because it is at the midpoint. It is at the mid of the lens. It is at mid of lens. Okay, sir. About the principal focus, talking about this one. Talking about this one. So if the rays of light coming, so I would rather consider that I would prefer to draw the diagram from my end. What do you say? Let me draw the diagram. That is going to help us very much. That is going to help us. Let me draw the diagram for you. Fine, fine. So what will happen? What will happen if the diagram is being made? So how will it look? So this is a convex lens. This is a convex lens. So there will there be any principal axis? Yes, bacha, there will be a principal axis. How we consider that the principal focus came into the picture? Sir, we pass parallel light rays. Okay. So there are parallel light rays which are incidenting over here. And as per the nature, it is going to converge. It is going to converge and it will be meeting at one point. That is called principal focus. Convex lens. Right hand side. Okay? Done? Done. Similarly, for concave, how it is going to work? The principal axis, if the light rays are going parallel to the principal axis, sir, the property says it will diverge. According to the property, it will diverge, sir. It is going to diverge, but they will appear to meet. They will appear to meet. Yes, sir, we know that they will appear to meet at a point. Where? At focus. Where? At focus. They are going to meet over there. This is an optical center. Clear? Clear? This is how we can make principal focus for both of them. So for convex lens, it will be on the right hand side. For concave lens, it will be on the left hand side. Okay, sir. Okay, sir. Formation of image. What are the rules? Rules are quite simple. There are only three rules. Only three rules. If the ray of light going parallel to the principal axis, it will be passing through focus after refraction. But after refraction, there is no bouncing back of light. So if a ray of light going parallel to the principal axis after refraction going, passing through focus. Rule number 1. Rule number 2. If a ray of light passing through optical center, no bending. No bending. It will go straight. Okay, sir. Third one. If a ray of light passing through focus, it will go parallel to principal axis after refraction. So that is easy. Only three. Very easy. Only three rules. Only three rules. Let's come to the formation of image and the first one. And that is for the concave. That is for concave. Ray of light going parallel to the principal axis, it will diverge but appear to meet at focus. Appear to meet at focus for concave. Second one, even in concave lens, the light will go undeviated. The light will go undeviated. Yes, sir. And the third one, finally, formation of image. There are two would be required and that would be done. Two would be required and that would be done. Formation of image, when the object is at infinity, the image will be forming at focus. The image will be forming at focus. Exact. Array, let me give you an idea. All the 6 cases that we studied in the concave mirror, exact similar in the convex lens. Exact same. Only the refraction will be the change. Only the refraction will be the change. So what we have observed from here, sir, we observed that the image formed is that meets at focus. That is going to meet at focus. Second, nature will be real and inverted. Nature will be real and inverted, and size highly diminished. Point size highly diminished or point size. Clear? Clear? First case. See, according to new NCERT, yeah, that is debatable that the image will not form, but ultimately you will have to place some value, na? You will have to place some value. If the object is placed at focus, for example, and once you are going to solve the numerical, what exact value that you will be obtaining? When the object is kept at focus, you will be getting 1 by 0, 1 by 0. And 1 by 0 in mathematics, we know that that is known as infinity. So we need to consider that. If you do not want to take this name, name it as, name that. The object is very, 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 very far. Channa mama dur ke. You can name it as, no problem. Ultimately, we define in that manner. We define in that manner. Right, right. So don't worry. Don't worry. The concept will not be wrong at all. Don't worry about that. Fine. Case number 2. When the object is beyond center of curvature. Object is beyond center of curvature. Here the object is being placed. Rules. So parallel to principal axis passing through focus, and from optical center it will be undeviated. The image is obtained. The image is obtained. And what you have found? Sir, image is formed. Image is formed between, point number 1, between F and C or 2F. Either you can write twice of focal length or you can write center of curvature, one and the same thing. Second, it will be real and inverted. Real and inverted. Size will be small, diminished. All the 6 cases similar to the concave mirror, bacha. The only thing is there will be only refraction. There will be only refraction. That is the only thing. Fine. Third one, when the object is at center of curvature, follow the rules. Parallel to principal axis, passing through focus. Yes, sir. Yes, sir. Sir, passing through optical center, no bending of light. Ultimately, you will be getting image at 2F. 2F. Yes. So what you are going to write? Sir, image first forming at 2F on right hand side. Second, same sized. Size will remain same because it is at center of curvature. And third, sir, nature will be real and inverted. Nature will be real and inverted. Yes, sir. Next, object shifted between center of curvature and focus on the left hand side. Parallel to principal axis, passing through focus. Yes, sir. And the second one, optical center, no deviation. No deviation. Where is the image? Sir, beyond center of curvature. After 2F. After 2F or beyond center of curvature. Yes, sir. Yes, sir. So in that case, image first beyond twice of focal length. What about size? Look at the size. So that appears larger and last. That appears larger and last. And nature, sir, that is real and inverted. Nature is real and inverted. Yeah, right? Right. Next, when the object is at principal focus. When the object is at principal focus, in that case, what will happen? What will happen in that case? When the object is placed at principal focus, where the image should be formed ideally. If the object is at focus, where the object should be formed ideally. Tell me if the object is at focus. Tell me if the object is at focus, where the image should form. According to the new NCERT, sir, the image will not form. The image will not form. Yes or no? Yes or no? This is what going to be happen. Yes? Yes? Optical center. Focus. This is 2F. Now I am placing the object over here. I am placing the object over here. Where the image is going to be formed? Where the image will form? Tell me fast. Fast. Everyone. Sir, light parallel to principal axis. After refraction, it is passing through focus. That's focus. And the light ray which is passing through optical center will be going undeviated. That is going to be undeviated. It is like that. Will they meet? Are they going to meet? No, sir. They are parallel. They are not going to meet. Image will not form. But one thing that I can say from here, the image somewhere at a very, very far distance, if I'm going to place any screen. So in general, what we say, so in the image will form at infinity. This is the answer that I was trying to give you. At infinity. I don't know what is the distance. I don't know what is the distance. The very, very, very far. Chandamama dur. Second, size will be, sir, highly enlarged. Size will be highly enlarged. And what is the nature? Nature, I mean. Real and inverted. Real and inverted. Yes. And the last case, when the object is between optical center and focus. Between optical center and focus. So the object is kept over here. Rules, parallel to principal axis, passing through focus. Sir, optical center, this will be like that. Now they are in a diverging manner. So we will be emerging it back. Appear to meet. Where? Sir, on the same side of the lens or the same side of the object. Same size as object on the left hand side. Okay. So the image forms on same side as object. Same side as object. First thing. Size enlarged. It seems large, right? It seems large. And third, because the light rays are appearing to meet, what will be the nature? What will be the nature? Appearing to meet. What will be the nature, bacha? The virtual and erect. Virtual and erect. How does the lens give real and inverted image? That is quite simple. When the light rays are incidenting, we need to place a screen and you would be able to see that. You would be able to see that. There is no problem. Right? We only need to put the screen in front of that and you would be able to observe the images. Right? There is no problem. No problem. Right? Fine. What will happen in case of concave? Again, there are two cases. If the object is very, very far, parallel light rays will come. It will diverge, but they will appear to meet at focus. Now in this case, image, where it is going to form? Sir, at focus. It will be point sized. But they are actually not meeting. They will appear to meet. So nature will be virtual and erect. See, these are the diagrams that you need to be very proficient in that. Like if you are able to draw the diagram, then it will be wonderful in the board examination. As this is a one-shot series, that is one of the reason I came up with the diagrams. But although generally I prefer to draw the diagram, so you also need that much practice so that you are drawing the diagram and that is going to help you out. Fine. And the last case, when the object is placed anywhere between optical center and infinity. So what you will be observing? If I cap the object over here, that is going to parallel to principal axis, appear to meet at focus, and the light ray which is passing through optical center will go straight. Finally, I have got the image over here on the same side, a smaller size, virtual and direct. Yes, sir, this is what we have got. So the image property that you are looking at, that is first of all, where it is meeting between optical center and focus. Second, diminished or small sized image you will be getting. And third one, the nature will be virtual and erect. Any problem so far with the formation of image? They are exactly similar to the mirror. There we were using reflection. Here we are using refraction. Otherwise, there is no change in the cases. We are getting exact same 6 cases for the convex lens, same as concave mirror, and 2 cases which was given in convex mirror, here we are getting in concave mirror. Right, right. Yes, sir. We have got this. What else? So these are the points. These are the 6 cases that we have seen. These are the sign conventions, exactly similar. Sign conventions are exactly similar. Right, right. You get the virtual images also in the lens also. Right. But as lenses are transparent, how do we get virtual image? You get a virtual image in the lens also. There is a possibility. There is a possibility. Right. Exact similar. The way we understood in the sign conventions in the spherical mirror, that is also going to be happen. That is also going to be happen. Fine. Sign conventions, no change. Object will be always on the left hand side. Image on the right hand side, that will be positive. On the left hand side, negative. Height of object always positive. Real inverted image, height negative. Negative. So all the cases, all the sign conventions are exact same. Sir, what else? What else? So over here, the formula is changed. In the case of spherical lens, it gives you 1 by image distance minus 1 by object distance, that is equal to 1 by focal length, that is 1 by V, minus 1 by U, that is equal to 1 by focal length. What about magnification? So the magnification seems, sir, in mirror, that was M equal to HI upon HO, that is equal to minus V upon U. Here it is going to be HI upon HO, that is equal to V upon U. Minus sign eaten. Finished. V upon U. No minus sign in case of lens. Okay. Okay. Clear to everyone? Clear to everyone? So does all the lenses give real inverted image? I am talking about convex lens, bacha. Manal. There are 5 cases that we have studied so far. And that too in convex lens. So convex lens at focus and after focus, like between center and center of curvature and focus, at center of curvature, beyond center of curvature, at infinity, all 5 cases will give you real inverted image. There is only one case between optical center and focus. If you are going to keep your object at that point, you will be getting virtual and direct image. Otherwise, the rest of the images that you will be obtaining, that will be real and inverted only. Clear? Clear? Fine, sir. Power of lens, that is the last, second last almost, or you can say the last topic, that is power of lens. Power of lens, that I am wearing the spectacles, there would be some power in that. So power of lens will be defined as the ability of a lens to converge the light rays. Formula over here is, what is formula? Sir, power of a lens, that is equal to 1 by focal length, but in meters. But what if I am going to write in centimeters? 100 by focal length in centimeters. 100 by focal length in centimeters. So the formula is quite simple. Sir, P by 1 upon F, it has to be in meters, or P by 100 by focal length in centimeter. So depending on what is being given in the question. If the focal length is given in centimeter, 100 by focal length. If focal length is given in meters, 1 by focal length. Ultimately, you will be getting this value, and the unit of power of lens, that will be calculated or written in terms of diopter, represented by capital D. Unit of power of lens. Power, diopter, capital D, diopter. Okay. Next, what if the lenses are going to combine with each other? Like that, for example, there is one lens, there is another lens, there is another lens, there is one more lens. I am taking like 4 lenses together. Lens 1, lens 2, lens 3, lens 4. Then in that case, how we would be able to evaluate the total power of this combination? Very easy. Very easy. Don't get scared because of the diagram. See, the power of first lens is P1, power of second lens is P2, power of third lens is P3, power of fourth lens P4. Take the individual power of the lens, add them. Simple, add them with sign, be it positive, negative. Let's consider an example. If one of the lens is plus 3 diopter, second one is plus 2 diopter, third one is plus 1.5 diopter, and the last one is minus 3 diopter. What will be the total power of this combination? What will be the total power of this combination, add them. What you will be getting? Sir, P equal to 3 plus 2 plus 1.5 minus 3. This is going to cancel out. Power of combination coming out as, so 3.5 diopter. Positive. Positive 3.5. Answer is correct. Answer is absolutely correct. 100%. Mind blowing 7 crore. Perfect answer. Perfect answer, bacha. Very good. Now the thing is, there is one question related to the lens which is given to us, that says a 2 centimeter tall object, that means the height of the object given as 2 centimeter. Yes sir. Placed perpendicular to the principal axis of convex lens. Focal length 10 centimeter. 10 centimeter. Which lens we are talking about? Sir, convex lens. Convex lens it is. Convex, right? So in convex lens, the focal length is always on the right hand side. Right hand side, that means the sign will be so positive. Left hand side negative, right hand side positive. The distance of the object from the lens. Object 15 centimeter. But sir, object is always negative. Find the nature position size of image. That is V, HI and nature. This is what I need to calculate from here. Yes or no? Yes or no? What is the formula of lens? What is the lens formula? Sir, 1 by focal length, that is equal to 1 by V minus 1 by U. Value of focal length given as 10. 1 upon V minus 1 by object distance is minus 15. Minus plus. On the other side it is going to be negative. So 1 by V, that is equal to 1 by 10 minus 1 by 15. 1 by V, that is equal to, what will be the LCM? Hi? 10 and 15. 30? 30? Yes? So 30. That is 3 minus 2. That is equal to 1 by 30. The value of V is coming out as 30 centimeter. Now you realize the value of V is coming out as positive. That means the image formed on the right hand side. Yes sir. This is why the value of V is positive. That means if the object was placed over here, the image would be on the right hand side. Image would be on the right hand side. Yes. Now they are asking about height. Part 2. That is HI upon HO, height of image by height of object, equal to image distance by object distance, height of image. No idea. Height of object, sir, 2. Or image distance 30, object distance minus 15. Yes, cancel them. This is going to be 2. So HI, that is equal to minus 2 multiply 2, that is minus 4 centimeter. HI will be minus 4 centimeter, sir. Height is negative. What will be the nature? What will be the nature? What will be the nature? Sir, height is negative. The nature will be real and inverted. Nature will be real and inverted. Yes, yes sir, done. V is positive. Yes, so that is opposite. Height will be negative. Yes sir, negative 4 centimeter. Nature will be real and inverted. No doubt. No doubt. Yes, this is clear. This is absolutely clear. One more question. Now the question is given for concave lens. You can ask your question in the doubt section. Put down in the chat. So concave lens given focal length 15 centimeter. Okay sir. So focal length of concave lens. So focal length of concave lens, that is minus 15 centimeter. Why? Because sir, focal length lies on the left hand side for concave lens. Concave lens. Yes. At what distance should an object from the lens be placed? Where the object will be placed? That means U, so that it forms an image 10 centimeter from the lens. First of all, tell me, image will be virtual and erect in concave lens. That means on the left hand side. See, there were only 2 cases. Concave lens, remember that. So 2 cases, virtual erect, same side of the lens, same side of the object. That means the value of V is given. How much? Negative 10 centimeter. And object distance, I don't know. Also, they are asking about magnification. These are the things they have given, provided. So, the very first thing that I'm going to solve, that is 1 by f, that is equal to 1 by v minus 1 by u. So, 1 by focal length, how much? Minus 15, minus 15. 1 by v is minus 10, minus 1 by u. Clear? Clear? I have just put down the value, nothing else. What I am going to do? I am going to place minus 1 by u on this side, and I will take minus 1 by 15 on this side, and this will be how much? 1 by u, that is equal to minus 1 by 10 plus 1 by 15. Let's take LCM. I will be getting 30 again. So this will be minus 3 plus 2 and 1 by u, that is equal to minus 1 by 30. The value of u is minus 30 centimeter. Yes or no? Yes or no? Sir, magnification, fast. Magnification, second part. Second part, magnification equal to v by u with no negative sign. Value of v is minus 10. Value of u is minus 30. Magnification, sir, 1 by 3. Analyze it. Analyze it. Magnification is positive, which means virtual and direct image. If negative, then real inverted. Here it is positive. That means virtual and direct. 1 by 3. That is smaller than object. Image is smaller than object. That means diminished. And this is what happening in the concave lens. Na? Remember? Remember? Yes, sir. This question was asked. This was no. Okay. That was asked in 2025. An object is placed at a distance 30 centimeter from the reflecting surface of a concave mirror of radius of curvature 40. The image formed is. I am giving you 45 seconds to solve this. Everyone, try this question. Try this question. Those who are present, please try this question and tell me what will be the nature. What will be the nature? And those who are having using poll for the classes, please download this PyEnS Lab. That is going to help you out all the time for the poll. Not even on the PW app, on the various platforms also. That will be really helpful. How to analyze this question? How to analyze this question? Sir, it is a case of concave mirror. Object is placed, that means u given as minus 30 centimeter. Radius of curvature is 40. Radius of curvature is 40. That means focal length will be, sir, minus 20 centimeter. Image formed will be, draw the diagram. Draw the diagram fast. Fast, draw the diagram. Sir, this is focals. This is center of curvature. Object is placed here somewhat. Yes? Nature will be real, diminished or magnified. Sir, object is closer to pole. It will be magnified. Option number C. Option number C. Option C. Yes. No one even answered. No one even answered that. No problem. Maybe the poles are not appearing to you. Is it? Poles are not appearing? Fine. Fine. So these are the questions that you can even try. So once this is done, you can solve this question. Student want to obtain an erect image of an object using a concave mirror of focal length 10 centimeter. What will be the distance of the object? What kind of image it is obtaining? Erect image. What kind of image they are looking for? Erect image for concave mirror. Are they talking about the sixth case? Yes. Yes. What will be the distance of object? If focal length is 10 centimeter, the object will be less than 10 centimeter. Option number A is right. Option number A is right. Image of object placed in front of concave mirror, focal length 15 centimeter, is of the same size as the object. The distance between object and image. Distance between object and image, concave mirror it is. Concave mirror. See, if when you get the same size image, if you place the object at center of curvature, the image will be forming at the same point. Yes. What is the distance between them? So there is no distance. Answer is 0. This is how you can solve various questions related to lens. I'm giving you like couple of questions as a homework, so you can give it a try, right? So this question you can give it a try. This question also you can give it a try. So these are the questions which was previously asked, and you would be able to do that very comfortably after learning all this concept. So this is all from the one shot of light, very important chapter. So please read that, learn that, practice hard, and count on my words. That is going to help you out, and all the previous year questions and even the new questions would be comfortably, you would be able to crack that. For today, thank you so much. Have a great time. Take care. Good night. See you.